Myself, Supriya Anand, Assistant Professor, Department of Electronics and Communication Engineering, RIT. We shall see the experiments of Analog and Digital System Design Laboratory, BECL305. The experiment is to realize the ring counter. Generally, a ring counter is a circular shift register which is initiated such that only one of its flip-flop or the latches is at one state, while the remaining conditions or the remaining values will remain zero. That is nothing but with a zero state. The ring counter is a general shift register with the output of one last connected to the input at the first, then it is a ring, which means to say the previous output what we are having, that will be shifted one by one. That is nothing but a one register to another register, or one flip-flop to the another flip-flop. Typically, a pattern consisting of a single bit is circulated so that the state repeats every n clock cycle in a flip-flop are used. And it can be used as a cycle counter for n number of states. Here we can observe the pin diagram and the truth table. This is the pin description. We are going to make use of the IC 7495, and this works with the clock pulse, which is nothing but for every clock pulse we are going to provide, the value will be shifted to the next register. We shall verify the input lines, that is parallel input and data lines along with the clock pulse. And this is the truth table. We need to make the mode 1 at the beginning and give the clock pulse. So the data at the beginning will be showing the previous, that is a previous state. Once you are setting the value that is for the parallel input line, we can verify that is the value. You can observe here the value is being shifted. For this will be the clock pulse. Here at the first mode I am setting the value as 1 0 0 0, and for the next clock pulse, that is for the second clock pulse, the value 1 is shifted to the next line, that is for QB. And for the next pulse, the value is shifted here across QC, and for the next clock pulse, the value is shifted here, and this goes on repeating for every clock cycle. So therefore we call it as the ring counter. We shall see the circuit diagram further. We shall see the circuit connection for the ring counter. Here we have placed the IC of 7495, which is of 14 pin. We can make the circuit connection. Pin number 7 is connected to ground and pin number 14 is connected to VCC. Here we need to take the parallel inputs, 4 parallel inputs and 4 outputs. Pin number 1 is shorted with pin number 10. Here this is 7, 8, 9, 10. From pin number 2, we are taking one parallel input as A. From pin number 3, parallel input B. From pin number 4, parallel input C. From pin number 5, the parallel input D. These are the 4 inputs. Next, from the output, we need to connect from pin number 13. From pin number 13, connect to output A. From pin number 12, connect it to B. From pin number 11, connect it as C. From pin number 10 again, take the output as D. From pin number 6, we are taking a mode connection, and pin number 8 and 9 is shorted and given it is for clock pulse. In order to verify the circuit, first we need to active the mode here. Once the mode is active, I am going to provide the parallel input. Here I am going to give 1 0 0 0 as the parallel input. The same has to be reflected as output. So therefore I need to press the clock pulse. Once the clock pulse is pressed, whatever the input I have given 1 0 0 0, the same is reflected across the output, that is QA, QB, QC and QD. So here that means the value has been stored. Now I will disable this mode and press the clock pulse. For every clock pulse I give, the value should be shifted. Now I am giving the clock pulse, the value is shifted.
once again one more clock pulse, the value is shifted. So this means the value is 1 0 0 0. The values are being shifted as 1 0 0 0. For every clock pulse the value is 1 0 0 0. The value is shifted here. This is 1, B is 1, C is 0, D is 0, the A is 0. So this repeats for the ring counter.